Today we're going to be solving quadratic equations by completing the square. You can pause it here and read the instructions if you'd like to. Number one, to find the value of c that makes the trinomial a perfect square. All you have to do is take your linear term, divide it by 2, and then square what you get, and that is what c will equal. That's it. So we could write it x squared plus 22x plus 121, and what that means is I could make this x plus 11 squared. So that's where that perfect square comes in, but your answer, all you have to do is find c right here. Number 2 says solve the equation by completing the square, round to the nearest tenth if necessary. So we have x squared minus 8x minus 1 equals 8. The first thing that you're going to do is get all the constants to the right. So I'm going to add 1 to both sides. And I would get x squared minus 8x equals 9. Now I'm going to complete the square. So I'm going to take my linear term, divide it by 2, and then square that. Now I get 16. I'm going to add that onto both sides of the equation. So I would get plus 16 here and plus 16 there. That is my completed square. Now the next step is you're going to find this perfect square. So I would take the square root of the x, which is, or the square root of x squared, which is x, the middle sign, and the square root of my 16. 9 plus 16 is 25. And then you solve for x because you're solving the equation. So I take the square root of both sides. I get x minus 4 equals the square root of 25, which is positive and negative 5. Isolate the x by adding the 4. So x equals 4 plus or minus 5. So 4 plus 5 is 9, and 4 minus 5 is negative 1. Those are my answers. All right, the second equation is a little different because I have a quadratic term other than 1. So anytime that you have that, you're going to have to, first move any constants to the right, and then you're going to have to take out anything, factor out anything in front of the quadratic term. So I would factor the left side of the equation like this. Okay, now I'm going to complete the square. So take the negative 2, your linear term right here, divide it by 2, and square it, and you would get 1. So I'm going to complete the square by adding my square there and onto this side. But now I have to balance the equation, right? That's why I'm adding the 1 on this side in the first place. But it's not just 1, it's 1 times this 5. So if I'm adding 5 on the left, I have to add 5 onto the right. So then to complete the square, I would say 5. The square root of x squared is x, a minus sign, and then the square root of 1 is 1, equals 28, because 23 plus 5 is 28. All right, now you're going to have to solve for x. So I would divide both sides by the 5. What happens here is that you get a decimal. All right, so let's see. 28 divided by 5 is 5.6. So then I'm going to take the square root of both sides. So I'd get x minus 1 equals positive and negative. The square root of 5.6 is, it's 2.366431913. I'm just going to round. So I'm going to put 2.366. That's good enough. Okay, now to solve, I'm going to add that 1 to both sides. So when I do this, the directions say round to the nearest tenth, so I can do that in the end. So I get 1 plus or minus 2.4, right? Because if I'm rounding to the nearest tenth, do that. So 1 plus 2.4 is 3.4, and 1 minus 2.4 is negative 1.4. So this is how you do it when you have a coefficient other than 1 in front of the quadratic term. That's how it's different from 2a.